Hello there, Mr. Sutton here, bringing you the IM374 Extra Practice number 3 solutions on right triangle trigonometry applications. On this daring problem, you're standing on a platform getting ready to swing from a rope attached to a tree in order to drop into the little river. Your friend's waiting in the river below. She's across from your position 25 feet away from the riverbank, and you spot her at an angle of depression of 56 degrees. We want to know how far you're going to drop before you splash into the river below. All right. So we're talking angle of depression. That's an upside down triangle. So just in terms of what's happening in real life, you're up here at the top left of the triangle. Your friend is down here in the river. And we said that she's 25 feet away from the riverbank. So I guess here presumably is the riverbank. This distance of 25 is the same as this distance in the triangle up here. So we'll put a 25 feet up there. And now 56 degree angle of depression. So angle of depression is between the horizontal and the hypotenuse sides of our triangle. So there's 56 degrees in there. How far will we drop before we splash into the river? So that's this vertical drop right here. And in order to figure that out, we need to look at what sides of the triangle they gave us. So we've got the side across from the angle. That's the opposite side. This 25 feet is the non-hypotenuse leg of the angle, so that's the adjacent side. Opposite and adjacent is the TOA part of SOHCAHTOA, so that's tangent of theta equals opposite over adjacent. So we can write tan of 56 degrees equals, and now we're going to have our opposite side of x over our adjacent side of 25. Now to actually get x, we have to multiply both sides by 25, so 25 times tan of 56. And let's see what that is on the calculator. So plugging that in, we end up with 37.1, and that's going to be in feet. So on this one, we have old man Bernard notices his grandson Timothy is stuck in a treehouse, and Bernard's 90 feet from the base of the tree. His angle of elevation to the treehouse with Timothy is 33 degrees. How long will a ladder need to be to reach Timothy, assuming that old man Bernard cannot move any closer to the tree before putting up this ladder? So we have an angle of elevation. That's a right side up right triangle. Here's Bernard. Here's the treehouse. And we're 90 feet from the base of the tree. So that's this distance down here is 90 feet. Angle of elevation is 33 degrees. So that's between the horizontal and the hypotenuse right here. And how long will the ladder need to be? Well, the ladder is this hypotenuse here going from Bernard to the treehouse. So we'll put an x up there. And now to find x, we're going to have to use a little SOHCAHTOA on this one. It looks like we have the hypotenuse that we're looking for and the non-hypotenuse leg of the triangle given. So that's the adjacent side. So we have adjacent, hypotenuse. That's the ka part of SOHCAHTOA. So cosine equals adjacent over hypotenuse. So then we can write cosine of 33 degrees equals the adjacent side of 90 over a hypotenuse of x. And then to get x, we multiply by x and divide by cosine of 33. So we have 90 over cos of 33. And let's put that in the calculator. So plugging that in and pressing enter, we end up with 107.3, and that's going to be in feet. So that is a very long ladder. We're taking a trip to Italy for this problem. Leaning Tower of Pisa, pretty famous. They're saying it's 55 meters tall, and the top edge of the tower leans out 5 meters from the bottom edge. We want to know the angle between the ground and the tower. Well, this is an angle of elevation, basically. So we're going to be using a right side up right triangle. And now just kind of getting a visual here, this hypotenuse is actually the side of the tower. And I know it doesn't lean that much in real life, or else it would be the falling Tower of Pisa. But we're just drawing a triangle just to have something to work with. So 55 feet tall. Well, this tower over here, this is the height of the tower is over here, but it also corresponds to this side of the triangle here. So this is going to be 55 meters rather, not feet, 55 meters for that side of the triangle. And the top edge of the tower, which is up here, leans 5 meters out from the bottom edge. So that corresponds to this distance down here. We'll call this 5 meters. We want the angle between the ground and the tower. That's this angle right here. So to get this, it looks like we have the side across from the angle, which is the opposite side, and the touching side that's not the hypotenuse, so the adjacent side. Opposite and adjacent gives us TOA, part of SOHCAHTOA. So that's tangent equals opposite over adjacent. So we can write tan of x equals our opposite side of 55 over our adjacent side of 5 here. And then to actually get the angle, we need inverse tan of 55 over 5. Let's see what that comes out to on the calculator. So doing a second tan and then 55 divided by 5, press enter. We get about 84.8 to the nearest tenth there, and that's going to be in degrees. On this problem, we have Jenna flying a kite. She's letting out 100 feet of string, and the kite is 75 feet off the ground. We want the angle of elevation. Well, that means we need a right side up triangle for angles of elevation. So here's the kite up here. Here's Jenna down here in the lower left. So this 100 feet of string, that corresponds with our hypotenuse of this triangle. And then the 75 feet high, that's the height above the ground, so that's this vertical distance here. Angle of elevation is always between the horizontal and the hypotenuse, so that's this angle down here. To find this, we notice that we have the side across from the angle, so the opposite side, as well as the hypotenuse. So that's the SO part of SOHCAHTOA. Sine of theta equals opposite over hypotenuse. So we can write sine of x equals my opposite side of 75 over my hypotenuse of 100. And to get the angle, now we need sine inverse of 75 over 100. Let's use the calculator for that part. So on the calculator, I just do second sine to get that little sine inverse, and then 75 divided by 100 in there gives me about 48.6 degrees. For this problem, we have a boy flying a kite, letting out 300 feet of string. Angle of elevation with the ground is 38 degrees. They didn't say angle of elevation, but that's what it is. Assuming your string is straight, we want to know how high above the ground the kite is. So since we have an angle with the ground, that's a right side up triangle. Again, we're letting out 300 feet of string. So that's this hypotenuse here, because the kite is up here and the boy is down here. So this is 300 feet on that hypotenuse. Angle with the ground is 38 degrees, so that is going to be down here. And then we want to know how high above the ground the kite is, so that's this vertical distance over here. Since we're looking for the opposite side across from the angle there, and we've got the hypotenuse, opposite and hypotenuse, that's the SO part of SOHCAHTOA. So that's going to be sine equals opposite over hypotenuse. So we can write sine of 38 degrees equals opposite side x over hypotenuse 300. And to get x, we multiply both sides by 300, so that's 300 times the sine of 38. Let's see what that comes out to on the calculator. So pressing enter after plugging that stuff in the calculator, we end up with 184.7, and that's going to be in feet. For this one, we have a ramp that's 60 meters long and set at a 25-degree angle of inclination. If you walk up to the top, how high off the ground are you going to be? Well, angle of inclination, we have a right side up triangle. The ramp itself is 60 meters long. That's this hypotenuse of the triangle, because you're starting at the bottom and walking to the top on this incline, so 60 meters. 25-degree angle of inclination, so that's going to be, it's basically angle of elevation, so that's this angle between the horizontal and the hypotenuse right here. And how high off the ground will we be? Well, that's this vertical distance over here. So since I've got the opposite side that I'm looking for across from the angle, and they gave me the hypotenuse, opposite hypotenuse, that's the SO part of SOHCAHTOA, so sine of theta equals opposite over hypotenuse. So then sine of my angle, 25 degrees, equals the opposite side that we're looking for, the x, over my hypotenuse of 60. And to get x, we just multiply the 60 by both sides, so 60 times sine of 25. And now for the calculator, so plugging that in, we end up with 25.4, and that is going to be in meters.